In this example, we have an HR dataset, and as an analyst, I need to understand what caused attrition in my company. This is what you usually get from every data visualization tool on the market: a list of attributes and an empty canvas. But what now? Drag and drop? There are millions of combinations in this dataset. Where do I start? One analyst might feel that salary is a key factor, while another might think that some of the company facilities are not attractive, and we should really look at the office locations. We can arguably claim that our two analysts might come up with completely different insights. The reason is not because they are bad analysts, but when faced with an empty canvas, the exploration path and as a result, the data insights will be based on the analyst's past experience, or bias, and imagination. So how do we eliminate the analyst's personal bias from the equation? This is why we added the capability for the system to analyze any attribute in the dataset and explain to the user various aspects of that attribute. All the analyst needs to do is point to the attribute, in this case, attrition, and ask the system to explain it. The first thing that we will provide is the basic distribution of the attribute values across the dataset and its breakdown against each one of the measures that are available in that dataset. The system found that actually there are 4 attributes that seem to drive attrition in our company. They are overtime, job role, job level, and stock option level. We have now narrowed our analysis from 37 different columns to just 4, dramatically reducing the problem space. Also, we can see the distribution of attrition across each one of these attributes, and I'm really interested in overtime and job level, so I'll mark those. We'll come back to those later. The next analysis found segments of employees in which attrition is either high or low. As an example, this second segment shows that 40% of the employees that chose to leave belong to a specific job role. Their job level is relatively low, and they have been with us for less than 4 years, and have taken overtime. I can now choose to focus on that group and continue to analyze, or I could execute a business action such as a specific retention plan for the employees that fit that profile. Lastly, we identify anomalies in the data, various places that attrition did not behave as we expected it to, as represented by the green line. Similar to any other chart that we showed, I can review the anomalies and select the ones that I'm interested in. This is an important step because our goal is not to generate a report for the analyst. Our goal is to create capabilities that support his analyses and exploration by providing him simple to use, sophisticated capabilities that help him achieve his business objective. By closing this screen, all the charts that the analyst selected are moved onto his canvas. He can now continue to interact with these visualizations just like he would have with any other visualizations that he would otherwise have created manually, such as perform year-over-year analysis or use it as part of an interactive story. But we managed to move from an empty canvas to a laser-focused analysis with just a few clicks, and without guessing or spending a lot of time dragging and dropping random items on and off the canvas. In this demo, we utilized 3 different machine learning algorithms without exposing the technical and statistical complexity to the business user. This is how the business can benefit from machine learning in daily activities. Data scientists are important, but if the shift to self-service analytics has taught us anything, it is that not every user can, nor should, get access to highly skilled resources, and not every business problem justifies waiting for a curated machine learning model.